So event-driven architecture patterns and messaging infrastructure with Rails and Kafka. Very long topic name. I'm Jesse. I'm the Chief Technology Officer at Kitomba. I don't do a lot of coding these days, but still like to play around. I actually changed roles in the middle of organizing this talk. So thank you a lot for AbleTech hosting this. And yeah, my GitHub's there. I will try and put up all of the code that I go through during this talk, but I haven't tidied it yet, so I'm just going to do that afterwards. It's been a bit full on at the new role. Cool. So yeah, it's a really huge title. We're going across like a lot of topics, but I kind of felt like if I skipped one of them, you wouldn't really get all of the context in relation to, the benefits and also the problems and kind of how you do it. I should give a kind of breakdown to say, this is really opinionated. This is based around like what I've learned over the years, and I'm not going into like a whole bunch of other options. So take it as you will, and definitely argue with me afterwards if you think I'm wrong. And I guess the other thing is that I tried not to. I tried not to make it about microservices, but obviously they're a big part of event-driven architecture. So I'm going to try and steer clear of it a little bit, but there'll be some context in it. Cool. So kicking it off, what's the difference? So all of you that are kind of developers will be used to a very common pattern, which is your kind of request or command-driven development. It's something that should happen. You're telling others what to do with the presumption that you'll get a response, and you're asking the question. Now, the idea with event-driven is that you're telling people that something has happened. You're saying what you have done, and there's no presumption of a response, and other parties will determine what they do as opposed to, provide that response. Now, that gets a little bit strange when you have kind of common, I guess, practices in web development where you're kind of, you go to a website, you get a 200 OK, there's a response, that request happens. So, yeah, I guess the reason why you would go towards event-driven architecture is because it's a more asynchronous form of communication. You have a lot of loose coupling of applications as opposed to tight, so you don't have to have interaction with everyone else. And I guess from a scalability perspective, it's kind of built in, like rather than making an API request to another service and expecting them to respond, that means they have to be up. That means they have to be able to handle the amount of requests you're throwing at them at one time. Whereas if you're looking at, a worker that's picking up an event, it can take them as it sees fit and kind of work on them at their own rate. So you don't need kind of circuit breakers or rate limiting built in. And I guess on the messaging front, it's got your kind of routing of your data built in. Yeah, and I guess there's a bit of a side of persistence to that message. Quite often when we do request-driven development, we're kind of looking at a request that we do some kind of action on. We might store in a database, but we don't say how we got there. So the original kind of raw side of that request is not persisted in a lot of cases, and is kind of lost forever at a certain point. Not sure how many of you know about this, but there is a standard for those kind of I guess more event-based messages with HTTP 202, which we can't always get away with when we're kind of doing browser requests, because you're getting a response back from a different HTTP service to say it's okay. 202 accepted is just the initial request saying, yes, I've received this and I'm going to go do stuff within the background and I'm not going to tell you anything about it unless you're kind of listening somewhere else. There is ways that you can kind of take that and I guess use things like WebSockets and all sorts of things to make that possible for a standard browser request. But I guess from a starting perspective, I was going to talk about a standard, HTTP request and a standard Rails app, I guess. So I've got an order app. It is a basic Rails app. It's a form. Nothing crazy about it. Sends the message. That's not event-based, obviously. That's just a request and response. It happened. The order was successfully created. I've done stuff with it. But if I jump into some code around that, I'm, getting that create event, standard Rails controller event, and out of it, I am turning the parameters into an event and publishing them. I'll get into a little bit more about the kind of topic and the Kafka app as we go through, but basically I'm doing the same thing I always would, the standard HTTP request with a response, assuming that this has successfully put the message on the queue that I'm using and save the order record. It's done. It's, dealt with. So talking about, I guess, the messaging infrastructure that you use in these kind of situations, it can get a little bit tricky. This is why I brought the messaging infrastructure side of the talk into it. Most people will have dealt with some kind of queuing system, whether that's like RabbitMQ or various different MQs, and you have this standard pattern where you have someone producing the message, a broker, and your consumers. Now, in a lot of standard queuing systems, that message is really persisted for a very short period of time. Potentially, it's only persisted until a single consumer has consumed that message, and it might not be able to be fanned out to unlimited amounts of consumers. I've thrown in this, very unreadable Kafka graph over here, where it's got a whole bunch of stuff hitting it. But I guess to talk about why I would use something like Kafka over RabbitMQ is that it's more of a streaming queue, in that the message that you're persisting into the broker is persisted, and it's persisted for a time period that you set. Now, in a lot of organizations, that could be 7 days, 30 days. It really depends on their requirements and how much data is flowing through. But it means that a consumer can pick that message up at any time and take that information and deal with it, even if it wasn't listening to it to begin with. So you could go back with 30 days worth of messages and go through that. And that's kind of the benefit of using something like Kafka, which is more streaming as such. Cool. The other kind of pattern, and I haven't done a code example of this, is an API gateway pattern. And this is kind of the same as you were looking at in the orders application, except instead of just taking a single request and dealing with it in the context of an order, you're actually having a gateway that deals with all the requests that might be coming into your app. The benefits of something like an API gateway pattern is that you're really exposing just that endpoint as opposed to the services that you're using behind it. So you're looking at like a single security message. You've kind of housed all your abstraction there and your tight couplings where your API doesn't want to change if you're receiving requests, and you can house all of your kind of authentication or concerns that you have across your entire code base. And I guess I just wanted to bring it up as it's quite a common pattern and very useful, but I'm not going to go into it too heavily. In the example that I've kind of shown briefly, we're pushing a request using Kafka. If you use Ruby on Rails and you're dealing with anything Kafka related, I highly suggest looking at Kafka. Again, it's quite an opinionated library, but it really deals with receiving and sending messages onto Kafka really well, and is really important. I guess the other thing that's really important when you are dealing with event-driven systems is that you have monitoring all the way through. I've set up kind of Datadog as an example that I'll take you through when we get to that kind of service portion. But to highlight it as being key is kind of, one of the most important things, because as soon as you start abstracting to multiple services and splitting into very small groups, if they go wrong in an event-based system, you are looking at, hey, that event never got picked up, but we don't have a customer complaining about it because it's not happened to them in a request-driven system. They haven't got a failure. They're still accepting it, that everything's going fine. And if it's not going fine in the background, you really do need to know about that. It becomes really key. I've kind of got some examples to showcase some of these problems and how you get around them. But the kind of main gist of it is that, if you change the events payload format, like what is the downstream applications affected by that change because you're just publishing an event, it might affect a whole bunch of services and you don't necessarily know what they are. This is kind of one of those areas where documentation is key as well, to put through and have a well-documented, this is who's dealing with it. But I think, and I'll show this, versioning is probably the biggest side of that. The other thing is finding where you get your events from. What does your particular app need to subscribe to? Where's it getting that? What's the data? What's the format? And how can I get to it easily? Setting up for something like this is a huge pain. If you're not kind of using generators or having a repeatable pattern to connect to your kind of common messaging infrastructure, then going back on it is going to be really hard. And you'll continuously just keep hitting setup over and over again. The other thing is that you want to keep it consistent, so that you're not, chasing down random bugs that come out of setup. A lot of people who are kind of working in the event-based space tend towards going to I've created a repo and I've added all my changes to this repo, and this is my base that I copy off. The alternative that I'm kind of suggesting is Rails application templates. Not sure how many of you would have touched them. They are quite often used by gems and Rails engines to kind of bootstrap their installs into your existing Rails apps. But there is guides on Ruby on Rails, but essentially, like when you're starting out a new project, you can just do Rails new. In this case, I've chucked in -- API because I'm not doing a web endpoint, and then I'm just specifying the template. And you can set up these templates in different ways, but we'll start into jumping into kind of what one of those would look like, and then pulling from this event that we've created in this first instance. So here's my Rails template. In it, I've built a few helpers that just copy directories and deal with the paths, as well as adding some gems and checking if they already exist, because you can apply a Rails template to an existing code base, as well as creating it from the default. In these helpers, I've added a whole bunch of gems. In this case, I've put in Datadog and DogStatsD, which just monitors the kind of underlying systems. And then I've got factory bot. Else. So when I'm setting up local environments, I'll have additional server. Well, the delay is real slow. Cool. So in the doc compose file, I've got a Kafka instance. I've got a Kafka kind of monitoring tool, and I've got my Datadog agent. So I can test everything that's part of that, and that will get applied as part of copying over my template. Oh, okay. Try cast again, maybe. Cool. Back up and running. Yeah, so I guess the other thing is that, connect up to Kafka and use their kind of opinionated install structure. So I can set it up beforehand. Now, opinionated instead of like a controller, we've got what's called a consumer. Yeah. What's showing on my screen is completely different. Okay. So yeah, a similar opinionated directory structure for consumers, and just like a controller, I guess you have your consumers, and I've written an example one here where it consumes messages off Kafka and prints them out. It's pretty basic, but all of that I'm copying in as part of my setup template, adding the gems, running bundle install, setting up my initializers and my actual Kafka file where it's pointing to the Kafka server, and all the config is set up and ready to go. So basically, run the single command and your Rails app is already there and set up to start connecting and interacting with that topic. So we've got this order event. I think phone's slightly different because I didn't update the image. And, step one, I have generated a service and ran that command. And then all I've done is written a very basic consumer that takes the payload from that event, extracts the customer's email address, extracts the order number, and sends it to an invoice mailer. Now, that request that we've sent a while ago is still basically just waiting there. So my basic service is all ready to go. I can jump in here and run my Kafka server, which will just listen to those events off that topic and grab them as they come through. And you can see it's pulled an event and sent an email, or fake sent an email based on that event that we published before. So if I look at my invoice service, all I'm really doing is defining, the topic that it's listening to. It's V1 orders. I've got my consumer, as we mentioned, and my mailer, and it's really is just quite basic. And so, in this instance, I'm sending out an invoice to the customer for the order that they've created successfully based on that synchronous request. Have a different service. Oh yeah, there we go. And this one's for shipping, and it cares about these orders as well. And does a similar thing. It pulls the details out of the payload. No. It just your we should do this. Now, similarly, it's just sitting there waiting because I haven't started up at this point, but all the events are still sitting there. In Kafka. Now, what I've also done is created a V2 version of this. I've added in some additional info. Basically, I'm now asking for the customer's mobile phone. And on my V2 endpoint, I don't know if a real phone number. I can send through a similar endpoint. Now, I'm just using this as an example to kind of suggest why you change this, but in a lot of instances, you probably wouldn't do V2 for this because you're just adding a parameter to the request, and so it's not actually going to break your V1 consumers. So there's no real reason to go V2, but just for the sake of kind of showing this, I've done the same thing. So if I run this server, it's listening for both requests from V1 and V2. So you can see with the V2 orders, it's sending across the Twilio request as well. So sending off a text as well as an email. And then somewhere, yep, just here, it's also picked up a V1 request and just sent out the email. Now, the benefit of this is basically that you can deal with those kind of breaking changes nicely and still read from both endpoints. So if you've got old data that's sitting in that queue still needing to be processed, you can have those two separate sets running at the same time, and continue to support them. But the other thing is that really you're only changing what the consumer is reading. Your kind of back-end code to this, your shipping mailer, doesn't actually have to change. Or of a, it will see how that text. I've thrown it in the consumer in this instance because there was just a lot of code to write as part of this, and I was lazy. But the idea is the same. It's basically that you can kind of switch out between those kind of versions and not have to worry about it. Now, these services aren't communicating with each other. The shipping service has nothing to do with the invoice service. They don't have to know about each other. They don't have to interact. They're just pulling from a single event source. And any of these could be spun up at any time to continue taking these events on board. There's no real kind of interaction that you have to do with any service to put this up. So it really means, like, if you're in like larger teams, you can just split off and jump straight into this. I guess I mentioned this before, but pulling this data out of monitoring and making sure that you have kind of your services and those events coming through, so you can see if something's going wrong, is super important. And you can also see things like if the different versions are being used. If you had services that were interacting with each other on that same message, you could look at it from a distributed trace where you pass a trace ID across the messages, so that you're essentially seeing where it went over your whole system. I didn't want to code that, but it's actually not that hard. It's built into Datadog's Ruby gem. I actually was the one who originally did it on the Datadog Ruby gem. So, cool. And I guess you can see, if we look at it from a Kafka perspective, you can see these kind of topics and these message brokers that have these messages and how many of them are sitting there. So, in V1 orders, we've got 6 messages, and we've got 2 consumers, the event-based invoice service and the event-based shipping service. They're both up to date. They've all read all the messages, so they've got 0 lag. But if something wanted to pick up from it, they could choose to either start in the future and so not read the previous messages, or start from scratch. Cool. I stupidly decided to try and do a live coding exercise. So bear with me. Hopefully I can kind of talk about how easy this is when you have it all set up in a way that you're kind of doing this templating. So again, I'm just doing standard Rails command with API. I'm using the template, and so most of it should be running out of the box. So without doing anything. Also just started using a Windows laptop for work, so bear with me on that too. What did I call the service? Play service. Cool. So without doing much at all, I've already got kind of Kafka set up. It's already talking to my messaging service. If I jump in over here, I can flick something through to the example consumer that I've already set up. I've got this somewhere that I can copy paste it. Thanks. I was wondering if that was supposed to have a return message. And this service that I've just started is already receiving and available to have messages. So if I jump into this project, it's already got all the config and setup. Should I just copy and paste this because that's going to be a nightmare. Cool. I can set it up so it's listening to that v1 orders endpoint, which has got our event. And if I restart this, yeah. Oh, okay. Yeah. There. You can see it already pulling from these V1 orders all of these payloads that are already sitting there. Now, in this example, I was going to talk about delayed shipping. Maybe you've got your shipping service and your whole shipment's running behind. You want to send out a message to your customers. You can go back, grab all those messages within a certain period, and send it out based on this events data. And you can do that all without kind of interacting with any other system other than just the events that are happening on that side. And with very kind of little setup. That's kind of the basics of the interacting with those kind of events and messaging. But I skipped over it earlier. There's additional benefits to having all of your stuff in a streaming service like Kafka. When you start to get to data pipelines and analytics and data lakes, essentially that raw event level data is what people want to use to get insights out of how to run your business. And you have this single source for that self-service data. So you can kind of dump it straight out of Kafka into S3, for example. Or, and additionally, a data service could just connect straight to that event endpoint, read them directly, so they can get them real time. Everyone's probably been over Lambda architecture Lambdas in AWS. I think it's a bad name. Lambda architecture was around before Lambdas, and it's probably more about I shamelessly ripped off this diagram that doesn't really work that well on my slides, but basically being able to deal with those kind of real-time event messages, so you can give customers instant data, but also you could do batch processing of those events that you've thrown into S3. So from a data analytics perspective, having a single pipeline where you send through all your events that are happening in your system, it's kind of, without a doubt, the most important kind of thing, that you have all that detail. Now, the alternatives to this is that, you have a whole bunch of traditional kind of request response based services with their own databases, sometimes file storage, and a whole bunch of other different environments that you'd have to connect to pull out all of that information. You haven't got a single source. All of a sudden, you're configuring, 5 databases and pulling out from those kind of different structures into your data pipeline, so you can pull out useful information, which gets complicated. And then you're also dealing with, if I'm querying a database that's running in production to get that data out of, all of a sudden I'm slamming production with my data request, which is just to find out some analytics, and I've got to run a read replica or some other system to try and prevent flooding your production system. Whereas in this instance, all of the data that your system's working with anyway, any kind of updates that go onto it are coming through a centralized platform, and it's all getting out without anyone actually having to make direct queries to get it. And that's that whole event-based side of it coming up again. It's not request response. It's you can read it if you want. It's all available. As I mentioned, the whole microservices thing is, you'll see that a lot of the services that I've used look like microservices. That's because they kind of are. But you don't have to use them as part of doing event-based systems. There are ways that you can still kind of maintain that event-based system. One of the reasons I really like this Kafka gem that I'm talking about is that it has an active job plugin. So you could take that request, start an active job, it throws it onto your topic, and you've got that kind of message sitting there for anyone else to read that's in your system. You can still pipe it out into your data pipeline, but your single app can continue to just deal with that single event, and it doesn't have to go past that. You can still kind of sit in that monolith space while being event-based. It's not necessarily getting all the benefits, but there are definitely some. Yeah, that's kind of it. Does anyone have any questions?
Yeah. So what sort of problems do you think can actually lend themselves to this architecture? Like you did like an order-based sort of system here, but like other sort of
I think you can do it with kind of any problem to some degree. I think it lends itself well to when you start getting into larger organizations and bigger teams. A lot of teams have this problem where, you can only have so many developers working on a single application. So all the context for that application is in their head. They're working on it in that context. And then if another person, that organization that's running a different application needs to interact with it, they have to go ask the team, read documentation, make those requests, potentially kind of flood that system if they're doing too many of them, worry about kind of all of that in between. Whereas if you're using kind of event-based, you can jump straight into, hey, like that system's already publishing these events, I'll just grab them. I know it's not going to impact anyone. They're available. There's no kind of crossover context. I just need to know what pattern the event is, because I'm not dealing with that application directly. I don't need, to know the endpoint. I just need to know the, topic that it's getting published into in my messaging infrastructure and the format, and that's it. So I can deal with any updates in that context, but also I don't have to persist it afterwards. If I just want to send an email and get it out, that's done. I don't need to have a database backing my service. I don't need to be storing that data if I'm just doing something simple where it's like reading and sending. It's just done. Yeah. Does that kind of answer?
Yeah. So how do you
Just balance retention in Kafka versus like, I might need this data in a new service later. Like, for example, if you're storing all your events in Kafka forever, you're paying basically twice your database size, right?
Yeah.
Probably got to store it somewhere else so you can query it, but you want it in Kafka so you can add new services and use those events.
Yeah.
How do you find a good balance between how long you can retain something just in case and
I think it's really around your architecture that surrounds it. So, when you start talking about Lambda architecture, maybe you only need to have events for 30 days, but if you're storing all of the other data in S3 and a service needs to go back and grab them, well, they're still all available in a storage state that's, less impacting. But the other thing is that Kafka kind of works like a database anyway, so the file storage and networking speeds are really good. So you can get really good performance to actually be able to store large amounts of data if you just have a really big disk. So sometimes it's a cost concern, but it's really about how much do you need to do right now. I think the other thing that would come into it is, how long does it take you to respond to an event? So let's say my service is down, it's not reading those messages, so the shipping notifications aren't going out. How long does it generally take you to go from, hey, I've got an alert, to, hey, I've fixed that code? Because if your response time generally takes 7 days and you're only storing 7 days worth of messages, you're in trouble. So there's an element to how quick you can respond, but also you could just republish a whole bunch of events onto a specific topic if you wanted to, just to grab them and use them in a specific instance. So you're kind of open to lots of options there. Yeah.
Does Datadog have monitoring coming from really
Yeah, you can do it with Datadog. The other thing I guess I'd suggest in like Kafka used to be quite hard to manage. It was kind of built for these on-prem kind of setups, and that's because it used to have like a separate quorum controller. Actually, I skipped over this, but previously it used Zookeeper to deal with the quorum of the cluster. And at the moment, you can now use, they're calling it Craft, which is basically just like Kafka without Zookeeper. It's really simple. That's why I can easily run it in a Docker container and not have any worries, because Kafka by default is a clustered service. And if it is dealing with its own quorum, it's much simpler.
When you're running your pilot, have you been
It can do. Yeah, I think it depends. You can kind of make those decisions up front with analytics in mind. The idea generally what you would do with like a data lake is store raw data. So if it's in a JSON format, you would always store that raw JSON format. And for someone who's dealing with that data, maybe that's not the best instance, but that doesn't mean they shouldn't keep it that way. They might then do a transform across all of those messages to turn it into a format that makes more sense from a reporting perspective. And yeah, it definitely depends on your kind of data analytics team and that kind of thing. But yeah, you do want to try and keep it common. Is probably the main thing. It's probably not that hard to change the format if you're doing it across the board, as opposed to just like doing random instances of JSON versus YAML and that, it gets more confusing. Yeah. Any other questions?
That's how, like, how you deploy those consumers? Like, you just put them on the say, you just like Dockerize that consumer or Dockerize the whole app? Or you some way, like.
Yeah, I thought about talking about it, but was kind of getting into too many different topics. It kind of depends. I kind of think when you're dealing with small services, you might want to go down like more of like a mono repo approach where you end up chucking all the small services in a single repository. So, deploying might be easier, but in those instances, I'd still run a single instance of every service as opposed to trying to run like a big manager that does all of them. Docker is generally the way that I'd go, and it's kind of, become the norm. Either on kind of Kubernetes or just ECS on AWS. When you're kind of running those small services, it's
So
pretty
those,
cheap.
like, consumers will be in one instance.
Yeah, because it's just a single process that's sitting there and listening. The other thing I probably didn't cover is that I could actually spin up 5 of those consumers and they would balance the amount of messages that are coming in, and that's part of the scalability side of it as well. If I look at the system, this app is a group, and in this group there's only one consumer that's looking at the single topic, but if I start up another one, all of a sudden it'll split those into 2 apps in that same group where they'll manage their own offsets, so they'll only pull the same message on one of them and not the other, so there's no kind of none of that kind of duplication from that receiving perspective. And that's another reason why you could just scale up a whole bunch. Like, say you have batch messages coming in, like massive amounts of API calls all going from one space. You could just spin up a whole bunch of these services to deal with them in an instance and spin them down. There's no kind of massive problems of doing that, and all the offsets will still be managed and contained inside that kind of Kafka group. There are instances where you would have to fiddle with the partitioning, but it's probably not worth going into that because it's quite a complicated topic. But most people wouldn't have to touch it.
If a consumer goes down or consuming usage, so they will take that. Therefore, they will process that message for other strengthen to redistribute between themselves.
Yeah, so it kind of depends on what you're using to interact with Kafka, but in most instances, the library will have some kind of cutoff in terms of jobs. I think Kafka has like a dead letter queue as well, similar to other queues where you can kind of say this message wasn't read, here it is, I've just kind of put it here so that it's out of the way and not holding up anything else. And retries are kind of built in as well. And you can deal with kind of mass consumption as opposed, like in this instance, I'm pulling a batch of messages at one time and iterating over them, but you could do individual messages as well.